when when students convince themselves that they're going to watch the recording, they won't. Trust me, you're not going to watch the recording. So that's why I advise all students to attend the classes because that's what you guys paid for, right? To attend. So you need to attend. So let me open Notepad++. We're gonna use that to explain. Okay, this is Java here. So I'm gonna explain from the beginning, like what are we trying to do, right? Like what's the whole point of programming, right? So programming, right? Computer science in general, right? We are trying to solve real world problems through computers, through making apps, right? So, for example, most of us were not born yet, but back in the days when people wanted to talk to each other or communicate, they would send a letter, and then someone would come to fetch the letter, and then it gets delivered, and it would take a week or so, or even a month, or 3 months, even depending on the distance for them to receive that message. So if you had sent a message like, hey, how are you? It's just a simple message, right? To read and ask how the person is. So that message would take a very long time. And then developers or programmers, they came up with a solution to make an app which solves that problem. So for example, they made apps like Mixit, WhatsApp, Telegram, those apps to communicate at very long distances, and you get an immediate response. So computer science is mostly based on that. We're solving problems, right? So that's basically what computer science is all about. So what is the foundation of computer science? So computer science, right? Back in the days, they used to write code in something that we call binary, right? So this is binary. If you wrote semester test one, of which all of you guys should have written semester test one, there was questions about converting to binary and things like that. So binary is, in a way, the mother tongue of the computer. That's the language that the computer speaks. Zeros and ones, right? It might not make sense, but trust me, as I explain further and further, it should make sense. So zeros and ones, right? You might ask yourself, why zero, why one, and things like that. So and why zeros and ones? Why did they choose zeros and ones? So if you remember CDs, right? There's always two ways of storing information, right? You can store the information as its literal binary, meaning zeros and ones, or you can record it as sort of like sound, right? So there was a if you remember CDs back in the days, if any of you guys ever had that experience, a CD, if you try to copy a song from one CD to another, what would happen? It might have scratches, right? So that means the data might be lost. So pro developers came up with another way, which is binary, meaning we store the information in its raw form, like zeros and ones. Then when you try to copy from one file to another, or let's say one location to another location, you simply copy and paste those zeros and ones to this new location. So that means you don't lose data, you don't lose the quality. So that's why most of the time, if you try to copy an MP3 from one CD to another, there's a high chance that might lose quality. It don't sound like the way it is on the original CD. So that approach wasn't reliable. So they chose this technique, which is zeros and ones, where zero would represent that there is, in simple terms, it represents that there is a presence of electricity. And there is no, my bad. So there's no electricity, and then one is the opposite, meaning there is electricity, right? So you might ask yourself, why electricity? Remember, all devices are charged using electricity. For example, when your phone runs out of battery, don't you go look for a charger? You look for a charger, right? And then that charger is transferring what? Electricity. So since computers, they depend on electricity to live, us, we depend on oxygen, right? So we are somewhat different. So a computer needs electricity in order to live. No electricity, what happens? The computer switches off. So that's why they just chose any number. They could have said maybe two means that there is electricity, and means two means there's no electricity, and one means that there is electricity. They could have chose those numbers, but they chose what they chose because zero. Remember, zero represents nothing, right? So there is nothing. There's no electricity. So zero usually represents nothing, right? Then one represents that there is one thing, right? Or in a way, there is something. So there is electricity. That's sort of like what was going in their brain when they're coming up with this. So what is when you have those sets of zeros and ones, right? Like this, they form what we call the language of the computer, which is what we call machine code, which is the mother tongue of the computer. So that's basically the language that the computer was born speaking. And one thing about a computer, it's very stubborn. It only speaks those zeros and ones, that machine code. So developers, they were like, okay, if we're trying to communicate or talk to the computer, remember programming is in another way of defining programming is basically us trying to communicate with the computer. In order for us to communicate, for example, if you are Tsonga and I'm Zulu and we're trying to communicate, both of us need to have a somewhat understanding of each other's languages, right? So if you have a computer on this side, right? If you have a computer on this side and then you have a person on this side and they're trying to communicate, the person needs to know the language of the computer, and the computer that in this case, right, the computer doesn't have to know because the person who wants to communicate to it is this human being, right? So the computer is actually very stubborn. It doesn't want to learn other people's languages. So the example that I like to use is like taxi drivers in CBD. When you go there and you say let's say you go there and and then you're like Dumelang, give guy takes, right? You're asking how much is the takes, or even if you speak English, hello guys, how are you? I'm looking for a taxi that goes to this place or whatever, and then they'll start talking to themselves in their home language, in their mother tongue, and say, wemphunu uthini lo yazi angimuzwa umtshayeli ukuthi mangabe seka-ready ukukhuluma nami uzokhuluma nami. Meaning that when you are ready to talk to tell this person tell this person that when he or she is ready to speak to me, they will speak to me if they're serious. Meaning that he expects you to speak in his language. He's that stubborn. Think of this computer as what? As a Zulu. They might butcher me or come for me, whatever, but they know themselves. They're very stubborn. They don't, that's the only tribe that refuses to learn other people's languages. So that's the best example I can make here. So computer, think of it as like a Zulu person, very stubborn, doesn't want to speak any language other than their own. So obviously this person is forced to learn this language, right? So back in the days, programmers would have to cram zeros and ones and write. Imagine they're writing a whole program, a whole app in zeros and ones. That's very difficult. So programmers realize that wait, there's a huge issue here, right? We don't like having to suffer like this because if you've noticed something, people are bad with numbers. The human brain is very bad with numbers. That's why they literally hold competitions for people who are good in numbers because that's how rare it is. Human beings are very flawed when it comes to remembering numbers. We forget things like birthdays, our age, or some people's age, you see numbers. But if it had a label, somewhat of a name to it, it will be easier to understand. So the developers used to write in the mother tongue of the computer, which is zeros and ones, which is binary, of which they call it machine code. That's the name of the language. It's like, for example, English, right? That's the name of that language. The language of the computer is called machine code. So this is how developers back in the days used to speak to the computer. Remember, another thing we're trying to tell the computer is we're trying to tell the computer to do something for us. For example, send this when the person clicks the send button on WhatsApp, it should send whatever they've typed. So that's an instruction. You are instructing the computer what to do. So a computer can view it as like a sort of like a baby, right? A child. So you can tell the baby sit or remember when the baby is still young, the baby usually mimics whatever you're doing. So if you make a funny face, the baby also make a funny face. If you make a funny sound, the baby also makes a funny sound. So that's how the computer is. You can treat it as like a child. So you need to be very clear in things that you say. If you were to give a child a an egg and say, cook the egg, the child will just simply look at the egg and then maybe smash it on the floor because the child does not, you can't, they can't comprehend or understand your language. So there's always that barrier. So you'd have to find a way to communicate with that child or that computer in this sense. So they used to communicate in its own language because it's easier for it to understand because that's the only language the computer speaks. Then what developers did, they're like, wait, this is too hard. Let's come up with a better way. Then they came up with something called assembly. And if you're measuring computer science, when you get to computer science 3B, you're gonna learn this language. And trust me, this language is really no joke. You really need to understand what you're doing. So they came up with a language called assembly. So assembly, what it did, right? Assembly simply said, okay, okay, let's do this. Let's say in machine code, these three numbers, right? It means to yeah. Let's say these three numbers, this would mean the value 1 or something like that. This would mean the value 2. And then this would mean that we are adding, it's addition. So if you wrote these numbers in a computer, if I simply just give you a list of zeros and ones, would you understand that this is adding 1 plus 2? No, you wouldn't understand, right? Unless you are fluent in that language. So even if you are fluent, you can never cram a pattern. Have you ever tried cramming for a test? How difficult is that? Imagine trying to cram numbers, zeros and ones. So it's very difficult. So they came up with assembly, which simply stated that you can you see a sequence of zeros and ones, you can give them a short name, right? So they call it mnemonic, right? It is or something that we call a mnemonic, basically an abbreviation of a word, right? So for example, if you wanted to add two numbers, you can simply use the add command, right? So add, which is an abbreviation for addition, right? Or sub from subtract, right? So they came up with these mnemonics, or mul, M-U-L, which comes from multiply, right? So they came up with these mnemonics, which made coding easier because I would simply write a command and say add 1, 2. So this simply means add 2 to 1. You see, even if I'm not that good in programming, I can somewhat understand what's going on here because I see the add. I know what adding it means. It means to add things, right? To combine things, to form one new thing. So assembly came into the place. But the problem with assembly was that it's very how do I put it? It's very unique for that specific operating system. So it's like remember we have Windows, right, which is the Windows operating system. Then we have Mac OS, which is the operating system for a MacBook. Then we have Linux, which is a different operating system on its own. Excuse me. So we have all these different operating systems, right? You can imagine in the sense that it's three different people from three different backgrounds or cultures or races or whatever. They have their own different mother tongues or languages that they speak at home. So that means that in order for you to use assembly, you have to go and learn the mother tongue for that computer. So if you are making, that means you see how difficult it gets now. It means that if you wanted to make an app for Windows and make an app for a MacBook again, you'd have to go learn the mother tongue for Windows, which is the assembly for Windows. Then you have to go to learn the mother tongue for MacBook, which is the assembly for a MacBook, because they're all different. Remember, it's two different people from different backgrounds of life. It's like, for example, Tsonga meets a person from France. Two different tribes, two different philosophies. So you'd have to master that language in order to become part of that tribe in a sense. So assembly became it made the prob it made us evolve, right, as a human species in terms of technological, right? It became easier, somewhat easier to write programs, but it also came with its flaws. It wasn't perfect, right? So something else needed to be created. And another last important thing that you need to understand about assembly, if you want to make a program, just to say how Hello World, that's how simple program Hello World, you need to understand the physical parts of that laptop. So what do I mean by that? In a sense, imagine if you wanted to get your driver's license, they tell you that the department there, they tell you that in order to drive a car, you have to go learn the blueprint, how that car is designed. You must cram the model. You must know how the engine looks, how many screws are there in the engine, and also understand the physics. Why does the car stand still on gravel? Imagine you have to go learn all those things just to drive a car. So that's how bad assembly was. You have to go learn the the physical parts that the engineers made, which are the parts that are inside the computer. You have to cram and go understand what each part does so that you can simply write hello world. So things were going down back then when we were not, most of us were not born yet. So things were going down, developers were suffering. Then they said, you know what, we've made some progress, but let's make even more progress. Then they came up with languages like Fortran, C, C++, then also Java was in the picture. Yeah, it was early, I think 80s, the 1985, 80s. That's where Java was invented and things like that. Then there was also C++, which which became better because now you see this program of saying add 1, 2, you can simply say int A, right? And then int B, right? And then you say A is equals to 1, B is equals to 2, and then you simply, okay, let's create a third variable. Then you'd have int C, which stores the sum. Then you'd say C is equals to A plus B. So you see, this is way, way easier to understand than to master assembly, even though assembly is somewhat easy to learn, but remember the downside. You have to understand the physical parts of your computer. Imagine you came to UJ and you wanted to learn programming. You're excited. You're like, yeah, I'm gonna tell the computer what to do. I'm gonna do like very important stuff in life. And then they tell you the ComSci 1A, they were teaching you assembly. And then your first practical, they tell you you go to the computer lab, they tell you open the computer, they give you a screwdriver. And they say open the computer because you need to understand what's going on inside, which is the parts. Once you're done understanding all those parts, then you can do the prac. Imagine if that was the case. So yeah, something needed to be done. That's why they came up with languages like Fortran, C++. There's a lot. You can Google them. There's COBOL. Yeah, there's a lot of languages. So you see that the benefits of these languages, right? There's all of these languages. You stopped this whole, they stopped this need to learn how the parts are inside of the computer. So you can simply write hello world and C++ handles all those things for you under the hood. But the problem with that is that the computer, like remember we talked about the computer, it's stubborn. It only speaks its mother tongue language. So some translation has to take place. So these languages, right? You see, it's easy for humans to read, but the computer still doesn't understand the language. So even if you wrote it in C++, this is how it's going to be done. It's going to take that C++ code, translates it to assembly. Then from assembly, it translates it to the machine code, which is the mother tongue of the computer. So you don't have to worry about from this side going that way. You don't have to worry about that. All you need to worry about is knowing the syntax of C++. So you need to know how to form a sentence in C++, how a sentence is terminated in C++, all those things, right? Then you just simply write a sentence. That's it. You don't have to worry about the translation. Something that we call a compiler does the translation for you. So that's the beauty of languages like C, C++, and Java. And you can, another thing is that it's somewhat easy to read. You see, int. You can assume that, oh, this is from integer. So this means, oh, A is an integer. So that's the beauty of languages like C++. Who hasn't muted their mic? Yeah, you're only allowed to unmute when you have a question. The rest of the session, you must keep mute your audio. Else, it's gonna affect me and my explanations. Yeah, I'll lose my train of thought. So you had yeah, you can unmute and ask a question.
Yeah, thank you, sir. I just need to say, please save the video. Some of us data is running out now.
What do you mean?
Save the video, sir.
Oh yeah,
So that can.
yeah, it is recording right now. The thing is, you joined a bit late. You see here, you see this red circle here. It shows that it's recording. So everything I've been saying so far has been recorded. Then I'll upload it on YouTube as private, meaning only the people I send links to will see the video. So I expect you guys not to share these links. So yeah, let me continue. You can mute once you're done. Okay, let me fix this because where are you? Okay, I wanted to fix this hand because sometimes if I don't remove it, it keeps it there. So there's the C++, right? This is way easier than the other approaches, which is assembly or writing it. Hey, you have to be very, very intelligent to write it in machine code. Assembly, yeah, you can do it. It's not too bad, but it takes a lot of effort. So now, since we understand a bit about the background, right, of coding and things like that, I'm not sure where to start. Wait, did I put? Okay, I do have code blocks. So I'm going to explain. I think now we can just simply skip and go to the C++ code part, right? So I'm gonna create a new project, console application. Console, it means the terminal. It means the program is run via this black screen, this black rectangle. That's what we call the console or terminal. Or in Windows, it calls it the command prompt. One and the same thing. Remember, there's synonyms in English. So we have I'm gonna click go and then next and then next. Then I'm gonna name my project. But then before I do that, I'm gonna click these three dots here, right? To choose where I'm gonna store every single project that I create. So I would just save all of my projects under documents. Then I'll create a folder that's called code blocks projects. So code blocks projects or C++ projects, that's still fine. Then it's already selected, so I can just simply click select folder. Then now, unless if I decide to change the location again, but now every time I create a project, it's going to be saved inside documents folder, inside the code blocks projects folder. Then now I'm going to call it, this one I'm going to call it beginning, uh, beginning C++, right? Then I'm going to click next and then make sure you choose GNU GCC compiler here. Make sure by default it's going to pick it. If it doesn't, just make sure you click there and you choose the one that says GNU GCC compiler. Don't choose all the other things. You see, if you choose all the other things, for example, this one, GNU GCC compiler for Android. That's for people who are making apps for an Android. So don't be choosing random stuff here. Choose the one that simply says GNU GCC compiler. Then you click finish. Then it's going to load. For me, I usually have weird settings. For you, your project would show. So it's gonna show like this for you on your side when it loads. Then you simply double click here and then double click main.cpp and then you zoom in, then there's your code, right? So now I'm going to explain the different parts, right, of the C++ program. So I'm going to change the perspective. So come on. So view, perspectives, minimal, because I want it to be a bit big, full screen anyway. So yeah, so in C++, this is the formula, right? The syntax. Every C++ program needs to be like this. It needs to have at the top there what we call preprocessor command, right? So what is preprocessor? What is a preprocessor? A preprocessor, you need to somewhat understand English, right? In order to for your lives to be easier. So preprocessor, if I separate this, remember this is a conjunction of two words, right? So I'll just separate them. You realize that this is pre, meaning before. Processor. The word processor comes from the word process. Process basically means, in other words, is translation. Remember, C++ is written in a language that the computer cannot speak. So it has to be translated. So the preprocessor is a program that's called pre-processing, meaning before processing or before translation takes place. So this preprocessor here, you can imagine it's someone who gets called by the compiler, right? By the translator. We call this person to do specific task. How do we know it's a preprocessor command or preprocessor statement? It starts with a hash. If it starts with a hash, we know definitely it's a preprocessor command. And notice something, I want you to be very careful. It has no semicolon because it's not a C++ statement, right? It's not a valid C++. It's not unrelated to C++. Don't worry about that. If anything that's really related to C++, we put in semicolons. So this preprocessor command, right, it only does what you want it to do. So for example, there's multiple commands. Each command starts with the hash. So you say hash, you see there they are all of these commands. You can say hash define, right? Meaning define this, meaning create this. You can tell it to do that. Or you can say hash include, meaning go and fetch. It's like telling your dog go fetch. Basically, that's how a preprocessor operates. You just listen to your commands and then it executes the commands. That's it. No questions asked. If you tell it include this file, it's going to go look for this file and find where it's located and include it inside this program. So if you if you want to see what's inside the file, you can technically view it. But I wouldn't advise that because it's too complicated for a beginner, for a first year. But I will show you. You just simply right click on that file. Make sure the cursor, you see this straight line that keeps on blinking. Make sure it's somewhere or next to any word here. Then you right click, then you say open hash include file. Then this is what is inside the file. Remember, we use abo C out, C in. There they are. C in, C out, CR, C log. So we use all these things. So they are defined in there. So when you say hash include, you are telling it to go inside this file and then copy everything that's in there. Literally copy everything, right? So I'm going to copy everything and then everything that you've copied in that file, paste it where this preprocessor command line is at, which is line 1. So it's going to paste it here. Okay, I didn't copy well. So let me right click, copy, and then I'm going to select this, and then this is what it does. So that hash include actually does this. So it includes this. That's why when you use C out or C in, it sees, oh, it's there because when you see when you click build here or build and run, that's what it does. It goes and looks for that file. It copies and pastes whatever's inside that file in here. And one thing you should be very important aware of, right? I want you to know, keep track of something, right? You see this file, we have variable C in, C out, and CR. Think of this file as containing a toolbox. So these things are inside the toolbox. So we need to go up and find out what is the name of this toolbox. This toolbox, its name is after namespace. Namespace STD, which stands for standard, not sexually transmitted diseases. Don't get funny ideas. It means standard. They took it from the word standard. You see, standard, if you remove all these letters, you'll be left with STD. So standard. So it's the standard namespace, not the STDs that you guys think about. So this is the file. So that's why when you go down here, you have to tell C++ or the compiler that, listen, I want to use that namespace, STD, so that when I say C out here, it knows, oh, you're getting it from this toolbox. So that's why it's not gonna shout it to you. So I'm gonna undo this because that dash include already does that for us. So that's why sometimes having to explain every step of the code, it kind of helps you guys to understand what's really going on, so that you don't just copy and cram stuff and go in the exam and you fail. And another thing that I need to explain is this angle brackets. We call them angle brackets. You see these brackets here? They're called angle brackets. So these are called come on. These are called angle brackets, right? So these angle brackets, right? There's two types of ways you can include the file. You can put the file name in between here. So this will be the file name, or let me write it in full. Name of file, which is the name of the file. It goes in between these angle brackets. Then there's the second way, which is using double quotes, right? And then you pass in the name of the file. And your practical actually has header files. We call these header files, right? You see this is what we call a header file. Header file because in the sense that it's at the head, it's at the beginning of the app, right? It's at the top. You see, number one, that's number one. It's at the head. Think of it as like a horse. If you look at when a horse is standing, I gotta start from the front, which is the head, the nose, or whatever, or the head. Then you go and you travel towards its tail, right? So that's somewhat the reason why they call it header files. So this type of approach, right, to include a file, it will still work. Remember, even if I change this to this, my program still run because those two ways are valid. They're valid C++ ways. They work. But there's a very important thing you need to understand. When you use angle brackets, you are telling C++ that, listen, or the preprocessor that, listen, this file that I want to include, I didn't create it. Don't look in my file, in my folder. So wait, what's your folder? The folder is the folder that's created when you create the project. You see, this is my folder. So if I go inside here, this is when you use the double quotes, it means that the file is defined here. So it means start looking here. So that's why I didn't use the double quotes, because I don't have this file inside of my folder. Is it there? If you look here, is it here? No, it's not there. So why would I tell C++ to look for it there? So I just tell C++ look for it inside the standard language, meaning inside the C++ language itself. This was made by the authors of C++, the people who created the language. So I'm telling the preprocessor to go look for it there because I know it's definitely there. It would still, I'm using that word loosely, right? And it would still look for the file inside of your folder, provided it didn't find it in the storage area for anything that came with C++. These angle brackets, in other words, it simply states that start looking for this file inside C++, because it's a file that I think it was created by the authors of the language. So that's what you're telling the preprocessor to do. You should start looking for it there. Then if it can't find it there, then the next logical place to look for is in my file in my project folder, which is here. So it does eventually look for it there. So both methods forces the preprocessor to look for the file in both locations, but remember, we need to speed up the process. We use the notation whereby the file is most likely there. So I use angle brackets because I know the file is most likely there inside the C++ language because I didn't create that file. And then when you use angle bracket, when you use double quotes, it means exactly the same thing. It means that it's gonna start looking somewhere, but now you're telling it to start looking for it in the current folder of your project because you assume it's a file that you've created. But if it didn't find it there, it's going to go back and look for it in the C++ language. So both methods, they do the same thing, but the difference is the way it starts. The angle bracket starts inside C++. So you usually include files that came with C++. Then there's double quotes. You use it only when you've made it, you've created that header file yourself. It's not part of the language. It's not part of C++. So I hope that makes sense now. Then using namespace standard, you're simply telling C++ that, listen, I want to use that toolbox. And you have to write it in full. You have to say using because I'm going to use it. And it's a namespace, meaning it's a toolbox. Then this is its name. It's std. Then you start using or calling things that are inside of that toolbox, which is the tools, right? The two tools that we have, I'm going to also cover input and output inside this lesson. Then I think next lesson we'll talk about data types. Then maybe after that we talk about if statements. Then after that for loops. Then functions. Yeah. No, the data types. I think we can talk about data types and then arrays. Yeah. So we have tools inside C++, right? So those two tools, in our case, okay, let me finish explaining the program. So we have an int main, right? This is what we call a function. Just like a function in maths, above f of x is equals to x plus 1. And then when you say f of 1, it simply means within that function formula, the formula that my function had, substitute that x value there. So 1 plus 1 will just give me 2. So it's exactly the same concept. Remember, computer science was created by mathematicians. So if you want to understand comp-sci related to maths, for example, int, if you remember in high school, x is an element of z, where z means integer. So yeah, it's made by mathematicians. So I wouldn't understand why someone would fail if you know maths, because comp-sci is really maths. It's just that there's extra things that you have to learn, but it's still maths. It's all maths related. So you can't run away from maths. So this means that this function gives you back an integer. Unlike in our real world, whereby when you create a function like f of x, and then you say x plus 1, you can insinuate, right? You can guess, right? You can guess that this function returns or gives me back an integer. You don't have to be explicit or very direct. Computers, they want directness, be straight. If you remember that meme, if you want to talk to me directly. Don't go through the corners. That's literally the motto of a computer. Don't go through the corners of the computer. It wants you to be very, very explicit. So if you were to create a function called f of x in C++, right, you'd have to tell it that, listen, this function returns an int and it's called f and it takes in x, which is an int. So you see, you have to be very explicit. You have to be very, very explicit. That's how computers work. They can't do guesswork. They're not prophets. They can't prophesy. So you have to be very explicit all the time. So when you get an error and you wonder why it's giving you an error, because you were not explicit enough. C++ wants you to be very explicit. So this function returns an int. I'm using the word return. Return is just a synonym for give back. It means it gives you back information of that type. So data type, it just means what type of things are we storing. So for example, you wouldn't park a car inside a microwave, right? Because a microwave stores specific types of things. like food, to warm up your food. And then a garage stores specific types of things like a car or your tools or boxes, right? So the same reason we have that in the real world, C++ has the exact same things. You can tell it what type of things this function gives you back, or in programming terms, we call it return. What type of things that does this function return? Which is integers. As you can see, I use the keyword return followed by a space. This space is very important because if I remove this space, you see, now it thinks it's a variable and then it crashes. Like I said, C++ is not something to take lightly. You need to be it needs precision, accuracy. There's no room for errors. So you need to put that space there and put in the value that you're returning. And this value that you're returning, it needs to match with this data type, which is an integer. 0 is an integer, right? So hence that's valid. But if you're trying to say return hello, then you get an error. So if I'll build this, you see, in that exact same line, I'm getting an error because this is not the type of thing you told me as C++ that it should return. C++ is going to be like, you told me this function returns a number, and the number, that's an integer, meaning it's an element of Z. This is a string. This is a whole word. So what happened to our agreement? We had an agreement. So that's what the computer is telling you, even though it doesn't speak, but that's literally what it's telling you. So let's check here. Invalid conversion from const char. So I'm gonna zoom in here. From const char pointer. Const char pointer, you talk about pointers later on, but const char pointer, in other words, just know it translates to a string. So it's telling you that it failed to convert the string to an int, which is this string here. To what? To int, because that's what the function expects you to return, which is an integer. So it's very important to understand everything that you're doing. Don't just cram. So here I'm going to remove this and put back that 0. That's 0 in C++, right? Zero simply means that tell the operating system everything went well. That's all that 0 stands for. So if you return a number other than 0, the operating system assumes that something went wrong. So that's all this 0 is for. Remember, C++ reads from top to bottom. It reads line 1, and then it goes down. It reads the line, reads the line, reads the line. It sees, oh, this is a function. Oh, this is the way it starts. There's the first sentence. Reads it, and then it gets to this point. So that means if no error has occurred and we've reached this line, simply assume everything went well, which is true because if you get to that line, everything went well. Because if you did something wrong, let's say you forgot to put the semicolon there, and then you build, you see that it's going to show you an error. That means you don't even get to this line. That means it stopped at this specific line when it was reading from top to bottom. So that's why we always return 0 to tell the operating system that, listen, something, if I manage to reach here, just know everything went perfect. Everything went well. And these semicolons, don't forget them. These semicolons, they are like full stops in English, right? Remember, they would talk, the teachers would beat they'll beat you to a pulp until you understand that the punctuation is very important. Put the comma where it's supposed to be put the exclamation where it's supposed to be put. In C++, I'll get back to you right now. In C++, you're supposed to put the semicolon, which signifies that this is the end of this sentence. But then we don't call it sentences in C++. They're called statements. So they're called statements. So yeah, you can ask a question.
Yeah, thank you. So, there's something which confused me in our language C++.
Yeah.
Some when we are writing the function like the one int main,
Yeah.
didn't put a semicolon, and but again, when we are in the topic of functions, when we put it in the main function, we put a semicolon, and then also for default, we don't put a semicolon. So I don't understand well where should we put a semicolon and where not put it.
So when it comes to functions, right? I forgot to explain
Yeah,
what this main function does. So when you click build, you see the moment you click build here, it looks for a function that's called main, and it returns an integer. So that's why this function will always be there. This function is very unique. It's not part of the topic of C++. You don't have to worry about it. This function, its purpose is simple. When you click build, C++ goes to that function and runs only the things that are here. That's why we tend to divide our code, because imagine if our code is a lot, we can't write 2000 lines inside this one function. That would be too much. So it's better to create multiple functions separately. Then we call those functions within the main function so that we break down our problem and we don't have messy code that's all over the place. So this main function is called, we call it the entry point. It serves as the entry point for compilation, for translation. It means that if this file is not, this function is not there, it's not even going to try to build at all or do anything. So let me delete this function and show you. So if I try to build here, you see there's no errors, right? Because I have nothing wrong. If I build and run, it doesn't even pop up because the compiler couldn't find the main function. So without that main function, you can't run your program. So it's totally different in its own case. You don't declare it, you simply use it. I want you to assume that it's already somewhere there inside C++ like this. It's already declared. It's a special case, this function. You don't do the way you've been doing other functions. You have to do it always this way, always this way. Because, excuse me, because what happens is when the compiler is translating, right? It looks for that main function. If it fails to find it, it doesn't even run. As you can see, there was no black screen, right? Which means that it failed to find the main function. So there's nothing to do. So this main function, it serves that purpose. That's the function that the compiler looks for. That's why you see my code, I'm writing it in here. If you were to do spiritual things like this, right? And you write this code outside here, there'll be an error because C++ was like, hey, man, what are you doing? Now you're doing spiritual things now. We told you in the documentation, in the textbook, that, or the authors of the language, they told you that you need to put all the statements inside the main function. Then you're putting it outside, doing your own spiritual things. Then it starts complaining at you. It's going to tell you that this is a syntax error because there's an error in your syntax. That's not a valid C++ statement. This, in the other way, it's different because here you're using the keyword using, because you're just telling C++ that you want to use this toolbox so that you avoid telling C++ where you're getting this tool from. So let me remove this. If I try to build again, C++ is going to get confused. It'll be like, what's this now? You would have to tell it, hey, listen, C++, listen, don't be too hard on me. This is a toolbox. This is a tool that I'm getting from this toolbox. These two columns, it means go inside this toolbox here and fetch this tool. So that means every time I use tools from that toolbox, I must always specify, listen, it's from this toolbox. I know it's annoying. So that's why we do that at the top using namespace so that we don't annoy ourselves and make that mistake. Because at some point you might forget to put that std : colon. So I'm teaching you the rules of C++ so that you understand how C++ works. So I hope that answers your question. The main function is different, it's special. That's why when you start C++, we always have empty like this, because that's what it expects you to do. You need to put everything that should be run inside the main function. Because when the compiler looks for the code or the instructions that you want to translate, it's going to look for the main function. Failure to have the main function, that means there's nothing to do because I couldn't find the main function. So if main function is very unique, it's its own special case. But other functions, yeah, it's a must. The functions that you create, it's a must for you to do that. Yeah, that was a very good question. Yeah, I like it when people ask questions because, yeah, I can't assume that you understand everything. So there's certain things that I might skip. Like, for example, I skipped explaining that this function is called by the compiler or translator, which is very important for you guys to understand. So, do you understand?
Yes.
Okay, that's fine. Yeah, then you can mute that we continue. So now let's talk about input and output. That's a very important topic. So remember, and another thing, don't I forget you guys are still beginners, like beginners. You see these Kelly braces here, right? They define what we call scope. In a way, if you think about it, right? Think about, yeah, this would be a perfect example. If you remember maths, you see, like I said, you can't run away from maths. If you thought ComSci was a way for you to run away from maths, think again. You're going to do maths one way. You could have chosen maybe accounting. Still, there's maths. So I guess the next possible thing you could have done is maybe become a bricklayer. That's the only thing you can run away from, use to run away from maths. Most of the things revolve around maths. You can't run away from it. So if you still remember in high school, you remember you specify ranges, meaning that if it's a square, it's inclusive, meaning it includes that starting point or upper bound or lower bound, and then it includes the upper bound if it's a square bracket, or if it's a round bracket, it means excluding. So if you still remember all those things, right? We use these brackets to define a range, just like these Kelly braces, they define a range for this function. It means that all valid statements that are part of this function should be within these Kelly braces. You put the statement outside, you say C out here. Yeah, it's out of range. In a way, it's like you're saying you're expecting C++ to accept 130 as a number that's within this range, which is invalid. So that's why it's going to show you an error. So if you say C out here and you say maybe just outputting J, it's going to shout at you because like, okay, this is not a valid C++ statement. So let me delete that. So it's going to shout at you here and be like, what are you doing here? Like, what are you doing? And notice one thing about C++, it's very bad at telling you what went wrong. So that's why I'm trying to explain as much as I can so that you don't make these errors. So make sure it's between these Kelly braces. They are there for a reason. They're not just there to make things look pretty. They're just there to define something. It's some, you see, we call in maths we call it range, right? In code we call it scope. It's called scope. So this defines the scope of this function. Then the moment when it says return here, right? You see this return here, it tells the operating system that everything went well, and it also exits or leaves this function. Leaves this function with immediate effect. So if you were to write code C out here at the end, so let's test it out to prove it to you. Hello. So my output should be hello world, and then end line, it means that it's so in a way it's like a full stop, like the line ends there. That means don't display anything after this. Display it on the next line. That's what ENDL stands for. In full, it's end line. Means end that line. Meaning don't display anything further on that same line. Meaning display it on the next line. Then I'll build and run. No. Don't make the mistake of running. You see, when you click run and you don't build, running is it's still running the previous translation. So if you make changes to your file, that's why I always advise to click build and run, because when you make changes to your file, it needs to rebuild it again, then translate it again, because there's new information, or else it's going to use the old translated file. So build and run. Do you see that it doesn't output hello? But wait, there's my cout statement for hello. Yeah, because like I told you, return keyword, it does two things. It tells that integer tells the operating system that everything went well, which is the 0. Then the return, it also exits the function, it leaves. So that means if you have a whole for loop or other functions called after return, never gonna run, even if you pray and fast, never gonna run. Impossible. So no, keep that in mind. I want you to understand return. Come on. So those people who don't attend and watch recordings, they're gonna miss out a lot because when you see when you enter semester test 2, right? You're gonna create a whole new project from scratch. You don't get code. So you're gonna write every single line from scratch. All those functions, you're gonna have files. When I say you're gonna have files, you're gonna have a lot of files. I think like 3 or 4 files, right? Excluding main.cpp. So it's really gonna go down if you don't really attend the sessions. So we discussed a lot. So let's talk about input and output. Then we should end our session. Then let me see how much. Yeah, an hour has passed. So I want to keep it under 2 hours the session. We can it can lead to exactly 2 hours, that's fine. But I want to minimize because I know the attention span of the brain. Yeah, the brain is very fragile, so you can't be pushing it too much. So I'm gonna say C++ is the language. So we have, what is this? We have okay, yeah, and there's a lot of explanations that are there. You're gonna have to bear with me, guys. There's a lot to explain. That's the thing. There's nothing I can do about that. So I have to explain a lot because there's a lot of things that you guys don't understand. So I have to explain that. So in C++, right, there are things that we call streams, right? Yeah, the diagram is gonna help out a lot. So desktop. So the diagrams help. I want you to picture how I'm viewing it in my mind. So streams, the way they work, right? You can imagine streams, right? It's like a pipe whereby you send something out. For example, a water pipe whereby water is traveling. I guess that's how we get water in our taps. It travels through these pipes, right? So you can imagine that water traveling through those pipes. It's like the information in our C++ program. So we can either receive information or send it out. So these pipes, they're called streams, right? We have streams. Just if you, I don't know if you've been in a lake or a river. I can see a stream of water, meaning it flows, right? In proper English or using the proper terminology, we say it's a stream of water, right? So it's like something that's flowing, that's traveling, right? So we can picture it in that sense. So in C++, it has these pipes, right? Or that we like to call streams, right? So there's two types of pipes. There's one for input, which we call input stream, right? Input stream, right? This is one for input for receiving information into our program, into our C++ program. Then there's another pipe for outputting information. And that information travels via a different pipe, of which we call output stream. Trust me, this will make a lot of sense when you start going to the code. It travels through the output stream. Okay, it doesn't want to behave. So this will be output stream, right? There's the output stream. Then we have our data, right? This is our data, our information, right? Another word for it is information. But I like to use data because it's the raw, right? It's unprocessed. So data is the right term for it. So we have these streams, right? So you can imagine there's specific pipes for specific things, which is true. For example, you have pipes for oil, right? Have you imagine what would happen if they switched it up? The pipe for oil, they use it to pump water. That means our water will have oil in it. Then we'll become sick and might even die. So that's why we have pipes that serve one purpose. They do that exact one thing. There's a pipe only for input. It's only for input. And then there's a pipe for output, meaning you're sending out thing. So we call these streams, right? Then we have what we call a buffer, right? A buffer is very important, right? So I'm gonna say this is a buffer. A buffer, you can imagine it as like a waiting area in a way. It's like, for example, when you go to see a doctor and they tell you stand in the queue. So it's like that whole queue, that list of people, it's a buffer. All those people in that whole queue, they're inside the buffer. So we have that buffer, right? And then we have our program, which is our app. It depends on which direction. Let me see. How am I gonna model this diagram? Okay, let me leave it like this for now. I'll refer to this later. So let's talk about input. So input, right? You receive input via the input stream. Okay, I have to actually use this. So imagine this is you. This is your terminal, right? This is the terminal or console, right? English is a problem. There's multiple ways to say one thing. Just get used to it. It's a terminal, console, or command prompt, whatever feels right to you. But they like to call it terminal console in the, I think in the practicals, they might say console. I think they'll say console. So this is console. Let's say you typing something, right? Let's say I type in 123.50, right? That's the information. Then what happens, right? Let's say you enter another number. Let's say you enter 120. And then you enter another thing. Let's say enter hello, right? So this is your input, right? This is what you've typed in the terminal. So what happens is that this is input, it's incoming data. So we need to store it in our program here. This is our program, right? This is by program, right? I mean, this is inside the main.cpp, where the main function is. This is our program, right? There it is. So we are receiving this data from outside, from an outside user, right? So what happens, the input stream, right? The buffer, it's meant to buffer data. This would be program, right? So the program is somewhere here. It's not actually there yet. It's somewhere here, right? This is the program. Then we would have a buffer here. Like I said, the buffer, the main reason for a buffer is to speed up the process of whether you're outputting or inputting data, to speed up that process. I'll give you an analogy for that. So this would be the buffer, right? So what happens is that if you don't use a buffer, C++ would have to travel one thing at a time. Get this, it travels through this pipe, and then it goes straight into your program here. And then once it's done, it goes back again to your terminal. It reads the next thing. Do you see how long do you see how much effort the C++ has to put into read that data? It's like, for example, you wanted to cook rice, and instead of taking that container for the rice and pouring the rice into the pot, you pick one rice at a time from the plastic. How long would it take you to cook the rice? It might take you 4 hours just to cook rice, because it's going to take you a lot of hours to take it out from the plastic and put it into the pot, because you are counting one by one. So what a buffer does is that instead of counting one by one, right? Instead of doing all of this counting one by one, it takes the whole chunk. So it takes chunks. So for example, instead of you taking one rice at a time, you pour it into a cup. So you see that speeds up the process by a lot. It speeds up, yeah, it becomes way faster. So that's the only purpose of a buffer. So the thing is, I can't drag and drop all of them at once. So it takes and then puts them in the buffer. Hey, you see now, this is what I do not like. The diagrams, when you try to make examples, they always have issues, man. I don't like it. So it's 123.50. Then we have 120 and hello. So it takes all of it here and puts it into this buffer all at once. It takes a whole chunk. And then copy, paste, and then this can be any number. Let's say 40, right? But then I want you to picture it as like it stores it in sequential order, right? In the order in which you've typed the values. If you entered 123.50 first, it's going to be the first thing in the buffer. And then you entered 40 next, it's going to be the next thing in the buffer. So it's going to be organize it in this way, like sort of like in a queue. Like I said, that's why I was making the queue when you're in the hospital. It's sort of like a queue. You can most certainly picture it in that sense. So this would be this, and then make it this color, this be this color. Yeah, so this will be the data in the buffer, right? I'm gonna do an example you doing this so that you understand exactly how the buffer works. And remember, this was input, it was incoming, so it traveled via the pipe for input, and then it was stored in the buffer. We stored all of it as a chunk, right? So there's nothing left in the terminal. It stored all of it as a chunk. Then and then our program, right? When you're storing it into the variables, Instead of going back to the terminal and then reading via the input stream, then storing, then going back there, then you see, that's too much work. Now it's like, it's our neighbor, it's right here. So I can get it straight from the buffer. So I can just read, remember starting from there, or I can just simply, let me fix this. Or I can just simply, let me stretch it a bit. I can simply organize it in this way so that you see that it is sequential. And then here, and then here, then there, then yeah, my diagram is a bit proper now. I'll share the diagram in the group. Don't worry about that. Then now your program, you need to write code, and that code needs to be within the main function in order for it to be valid or to run. Then that code, you're going to create variables and you transfer from this into your program, into variables into your program. So yeah, that's the process. Or for example, you want to output something. So if it was vice versa, right? Yeah, this is a perfect diagram, yeah, at least. So if it was vice versa and you wanted to output hello world, this is what happens, right? You create a variable inside your main.cpp and it has the string hello world, right? So imagine this was you. It has the string hello world, right? That's your program. Let's use some colors to make it look pretty. So you have this program, right? I don't even know. I'm just choosing random colors. So you have this, your main.cpp, which is that inside your main function. You have that text, a variable that with that hello world. Then you use cout. Remember, it is that word out, meaning it's referring to the output stream. So what happens is that it copies this thing and then it puts it in the buffer, right? Then from that buffer, it travels via the output stream. You see, it enters this side into the pipe, and then it gets displayed on the terminal, which is that black rectangle thing that you are seeing. So it goes in that order. So it goes from here to the buffer, then from the buffer to the output stream, then from the output stream to your terminal or any device. It could, in this case, we call it we have the standard, we have the output device and the input device, right? Output device is just a device whereby you send output to. In this case, we're referring to the terminal. It can be a file. You can actually write to a file using C++. You can literally write to a file using C++. So we'll get to file handling later. I think second semester, if I'm not mistaken, yeah, second semester. That's when you do file handling. Bit of exciting stuff, but there at that time, it's gonna be chowing. You need to be prepared. So we can, if you guys don't mind, you can, like during recess, we just continue paying as usual. Then we have sessions preparing and doing all the practicals that you guys gonna be doing in second semester, so that you have enough time for Maths 1B, because that's a beast on its own. It's worse if you're doing Physics 1B and Stats 1B. Hey, you chose the hard life. If you're doing all those 3 or 4 modules. May God and your ancestors be with you. That it goes down in those modules, especially if you have all that combination. So it goes from the program to the buffer, then travels via the pipe, it enters the pipe, and then that's why you're able to see it on that black screen. So that's why when I wrote cout here, that's what was happening. This cout here. That's really what was happening. That's why I was able to see it on the black screen. So if I build and run here, there's hello world here. And then there's that return 0. See, there's that return 0. So I hope you can somewhat understand C++ now, how it's structured and everything. So how do we refer? Remember, we're trying to refer to these pipes, right? The input stream and output stream, right? So that we can read from the buffer. So how do you refer to it? Remember, I use the terms input stream, right? And output stream, right? So there is actually data types that refer to the streams. They are called, one is called iStream, and then the other one is called OStream. O meaning the O stands for output, the I stands for input. That's literally what it stands for. If you remember that file that I was talking about, I think now you are having that aha moment where you're like, yeah, I finally get it now. If you remember here, remember Cin is declared as I stream, meaning it refers to the input stream. That's why we use Cin for input, because it's of type I stream, meaning input stream, because it refers to the input stream. And then O stream Cout, because it refers to the output stream. O stands for output. So I hope you can somewhat understand now. So how, in what direction do we need to understand this? I want you to look at it in this way. We have two operators. We have this operator and we have this, right? Operator, I mean just like plus or times or minus or divide. These are valid operators, these ones. And I'm sure you can understand why we use two of them instead of one, because C++, remember, C++ is very explicit. You need to avoid confusing C++. If the authors of C++ had only used one less than symbol, you would think that, oh, you're comparing if one value is less than the other. You see, it gets confused. So that's why we use two. And then here, same applies. If we use one, it would think, oh, it's a greater than sign, which is wrong because that's not what you're trying to do. So we have these two operators. This is what we call the stream insertion operator, right? Then this is the stream extraction operator, right? By insertion is to insert. That means we're inserting, we're adding it into the buffer, right? And then here, extract, we are extracting from the buffer. That's what it means. So when you say Cout, and remember, you need to use the object or the variable. In this case, it's fine. I'll use it. I would refer to them as variables because that's the word you know. But it's actually called an object. You learned that in second semester. So Cout, you need to use the right operator because Cout refers to us inserting, right? We need to insert. You can't do this. You can't use this one. I know beginners tend to confuse them. Look at the direction or try to understand what you're doing. Cout is meant for output, right? Meaning it needs to go to, okay, let me just explain them a bit. So this is Cout, Cin. Cout, this is common. It stands for common output. It's in your textbook. You can go check it out. And then Cin stands for common input, meaning input. It refers to input and output, right? That C stands for common. Or you can view that C as characters or console output or console input, whatever it feels right to you. Because remember, we're dealing with the console or the terminal or that black screen. So Cout, obviously, you use the stream insertion operator, right? Why? Because if you let's look at the diagram, right? Because it comes from my program and then it gets inserted. You see in the direction, look at the direction. I'm going to the left, it's towards the left. It's inserting into the output stream. So that's why when you use Cout, use the arrows that go in that direction because you want to output hello world into the terminal like this. So this gets inserted into the output stream. So that's why when you see out, you always use two less than symbols, which represent the stream insertion operator. Then when you use Cin, it's the opposite because this is what? Input. If you remember in our diagram, when I was doing the diagram, right? Remember the input comes from the terminal and it goes in that direction to the right, in that direction. Then it enters our program, which is our app, right? So that's why when we using the Cin, we use those two greater than symbols. And then here we put in the variable name. Always put in the variable name. And the variable that you put in here, right? Its data type. Remember this, when using Cin, it's going to read from the buffer. And remember what I told you about the buffer. It stores the things sequentially in that order, in the order that you've typed them when you are entering input. So if you pass in a variable of type string, and it's gonna crash because look in the buff. What do we have in the buff? We have hello. So it's gonna take hello and try to convert it into an int. Oh no, my bad, I rearranged it. We have 123.50. It's gonna try reading this. Okay, this will fine. This will be fine. It will be a problem if the first thing was a string and then you're trying to read it as an int. But that would be the problem. And the buffer is so special, right? You need to understand the buffer. You see this 123. If I read an integer from the buffer, 123.50 is not an int. It's a double. So what happens is that C++ is clever, right? It will look for only things that look like an int. So it's gonna read the value 1, it reads 2, it reads 3, it sees the dot, it's like, nah, that's not a number. So I'm gonna stop there. Then it stores 123 into the variable. I can even test it out now to show you that the answer would be 123. Then now what C++ does, since 123 has been read from the buffer, it's gonna delete this and leave 0.50, which is the same as just 0.50. So you need to understand the buffer. That's why I'm taking my precious time to explain the buffer. The buffer is complicated. You need to really understand it. So let's demonstrate this example, right? So I'm going to demonstrate this and do that. So I'm going to say int a, right? Then I'm just going to simply say cin, and then I store it into the variable a, right? I'm just simple output input. But sometimes it's important to output to the user and tell them what to enter. So that's why you always start with cout. Because let me show you what's the problem. Let's say I didn't put cout. It's going to run, it's going to expect input, but how would the user know that this means enter something? So it's a problem. So that's why we write text first. We say cout, then you say enter a number, right? And then space. Remember, the space is just for making it look beautiful, so that when the user is typing, there's that bit of space there. And then semicolon to terminate or to end that statement, right? You could put end of line character, right? But then that's a problem because now this number will be entered in the next line. So I don't want to do that when it comes to inputs. I always want to omit that end line so that it continues on the same line. You see, it's still on the same line. If I use end line, it will be asking input under E, which is here, which is wrong. So that's why I did that on purpose. So if you enter 123, I forgot to output. After here, we need to say cout A so that you see what the value of A is. So A, and then end line, end line. So you see that A will actually be 123 because like a buffer only reads what it looks like, the thing that it expects it to be. So if I say 123.50, you can also, do you know that the buffer is so weird, right? You can actually, because you can't expect the user to always behave. The user can enter more than one value or more than one thing. So let's say the user did this and say space, then they entered 50, then they said also hello. So what happens, all of this is going to be stored in the buffer in that exact order. So starting with 123.50, followed by 50, followed by hello, in that exact order. So that means the first thing that it expects you to read is a double. But then if you said an int, it's going to read 123. So if I press enter, come on. Yeah, my thing it has jammed a bit. So I'm going to say 123.5. Let me do that again. 50, 50, hello, enter. You see what I was talking about? There's that 123. So I didn't lie. So there's like some people, they say there's no cap in my rep, and didn't lie. It looked for the thing that looked like a number or an int. Remember, an int has no decimals. So a dot doesn't qualify as an int. So it stops at the dot. So what's actually left in the buffer, remember when it reads from the buffer, it erases what is in the buffer. So what's left in the buffer is only from here to there. So if I was to read the next thing, right, it will start reading from the dot. So be very careful of that. And if you entered something that it didn't expect, for example, if you entered a string, remember the buffer stores it in that exact same order that you entered the values. So if you started saying hello, followed by 123.50, followed by 50, crash. It's going, okay, it didn't crash, but it's supposed to crash. That's the problem with C++. This is wrong. It's supposed to crash. It didn't crash, but it's supposed to crash. So you'd have to do checks like if cin.fail. You have to always do those checks to check if the input stream failed to read. In this case, C++ doesn't just quit. I don't know why it does that. Yeah, you can ask your question.
Yeah, thank you, sir. Yeah, in the case that we are in, I don't know whether you explain it in this video or in the next one about associating the solutions and in the tutorial or cin. I think they put while cin.fail, cin.ignore, cin.clear. I don't really understand those things. Yeah.
Yeah, we'll cover those. The thing is, I'm looking at the time now. To be honest, I wanted to cover everything today. All those like all the functions. There's put back, there's peek, there's get. There's a lot of functions inside. There's a lot. That's the thing. Even the person who made the language, I'll send you a short video about him, the creator of C++. Even himself will tell you C++ is no one, there's no one who knows everything about C++. There's no one. Even him himself, the things he forgot that he created. So C++ is very big, like it's broad, and it keeps on evolving. What the language that the C++ is learning right now is the one that was released in like um around 2011, 2014. That's the C++ we're learning now. And the latest version is the one that was released in 2023. So you can imagine how behind we are. So this language is very broad. So it's going to take a lot for me to explain all those functions. So for now, I won't explain all of them. I'll just cover basic input. Then in the next video, then we go into the depth. That's why I made this diagram. So keep this diagram I'm gonna save it as an image and send it in the group. This diagram will be very important to explain about peek, about ignore, about all those functions. It's very important because those functions, they refer to the buffer. So make sure you guys keep this diagram. You save it on your phone or on your laptop. I'll share it in the group. So yeah, I will explain in the next session. So yeah, this is I think I should end it here because I think you guys are tired. The brain can actually focus attentively for a maximum of 45 minutes. So I've actually exceeded that time, but it's fine. You can, if something is that interesting, the brain can prolong that minute, that time. So that means you can basically concentrate for a way longer time than 45 minutes. If it happens that the brain finds that thing that it's watching as interesting or exciting. For example, when you guys watch a movie, it's an hour or to 2 hours or 3 hours sometimes, but you can focus. But then sometimes you lose focus at some point if you've noticed. So it's very important to also understand your brain. So I'll try to limit my sessions within 2 hours. Make sure most of the time less than 2 hours. So this is pretty much the input and output. There's quite a lot to explain, so I can't cover everything in one video. So we'll have a session tomorrow on that. Probably finish. We won't have a chance to talk about data types. We're mostly gonna talk about input and output tomorrow. So we're still stuck on one thing. I'm gonna explain cin.ignore fail. There's also good. Yeah. There's also cin.good. Yeah. There's also good. Like I said, there's a lot. There's good. There's also bad. There's a lot of functions, man. It's impossible to master all of them. It's impossible. So I'll just talk about the ones that I know from my brain. I don't have to like remember and think about too much. I'll explain those. Then the rest, it's research based. You go do your research, and they're probably most not gonna ask them. So yeah, that's it for today's session. I don't see the need of sending you this code. When you do proper code tomorrow, that's when I'll start sending the code as a zipped file in the group. So yeah, thanks for attending, guys. I hope you guys continue to attend. I hope you can see that C++ is not something to be taken lightly. Chows if you don't know what you're doing. And most of these things of C++, I learned them after my degree. So you'll be getting valuable knowledge or information from me because I now know quite a lot about it. So please normalize attending, guys. See you in the next session tomorrow. Hope you guys have a lovely evening.